Good day, students. In this clip, we're going to be reviewing an example on using the law of cosines to solve real-world application problems. All right. So let's take a look at question number one. It says Island A is 280 miles from Island B. The ship captain travels 180 miles from Island A and then finds that he is off course and 150 miles from Island B. What angle in degrees must he turn through to head straight for Island B? Round your answer to two decimal places. All right, so to get us started, let's identify or locate Island A and B somewhere on our grid. All right, so let's say Island A and B are located on those 2 points. In the first piece, we're told that the distance from Island A to B is 280 miles. All right, so let's draw that segment and put in the distance of separation between them, 280. And the ship captain originated from Island A and headed 180 miles to some direction before he came to the realization that he's off course. All right. So let's say that this is a point somewhere here where the captain realized that he's off course. How about we call that point C? Okay. Now we can create a triangle like this. Um, so he traveled 180 miles before he realized that he's off course. And he found out that he's off course by 150 miles. So 150 miles is how many miles he is away from his destination. All right. So it says, what angle must he turn through to head straight for Island B? So his initial direction was from AC, was something like this, heading in that direction, and he was going off course. So the question is, how many degrees must he turn to be heading right back to his correct destination, which is B? So this right here is the angle that the ship must rotate in order to head back to the right destination. All right. We noted that this angle is a supplement of angle C, so all we just have to do is find angle C and subtract it from 180, and that will be the correct answer. All right. So let's go ahead and find C. Now, what kind of triangle do we have here? This is an SSS triangle because you were provided with 3 sides. So if you have 3 sides for SSS triangle, you have to use the law of cosines in order to solve for any of the angles. All right. So we have SSS situation or SAS situation. These triangles, you use the law of cosines. All right. Now the law of cosines formula that I'm going to use here is the one with the big C in it. So we're going to use the formula C squared is equal to, let's call this A, opposite uppercase A. Let's call this B, opposite lower uppercase B, and let's call this C. All right. So the formula is going to be C squared equals A squared plus B squared minus 2AB cosine C. All right. Now let's put in the angle measures. We have 280 square equals 150 square plus 180 square minus 2 times, let's see, 2 times 150 times B is 180 cosine C. All right, so let's get cosine C by itself. To get cosine C by itself, all we just have to do is subtract these two squares from both sides of the equation. So we have 280 minus 280 square minus 150 square minus 180 square. And then we're going to divide both sides by 2 times negative 2 times 150 times 180. So let's go ahead and do that. If we divide both sides by that expression, it's going to shift to the other side of the equation. We have negative 2 times 150 times 180. Okay. So let's plug this into our calculator, and it will take the inverse cosine to figure out what the value of angle C is. All right, so let's go ahead and do that. We'll have, let's clear this. So we're going to have 280 square. Be sure to group the numerator in parentheses since you have multiple terms being combined with each other there. Minus 150 square minus 180 square. And that entire expression divided by negative 2 times 150 times 180. And the answer is going to be negative 43519. Alright, so let's write that down. That's going to be negative 0.43519. Alright, let's get angle C by itself. To accomplish that, we'll take the inverse cosine of both sides. So C is the inverse cosine of negative 0.43519. Let's put that in a calculator and see what we get. So we have the inverse cosine of the answer, previous solution, and we have 115.797. Alright, so angle C is 115.797. Now the angle that we have to rotate to get back on course is a supplement of 115.797. Alright, so let's call this angle theta, what we need to turn in order to get back on track. Let's call it theta. So we have theta from color. Theta is equal to the measure of angle 180 minus the measure of angle C, 115.797. Alright, let's put that in our calculator and see what we get. So 180 minus our previous result, and the answer is 64.2. So let's write that down. Theta is approximately 64.2. Alright, so what does this answer mean? What is the meaning of this answer? It means that the ship has to turn 64.2 degrees. 64.2 degrees, actually technically it should be negative 64.2 degrees, but 64.2 degrees to the right in order to be back on course, okay, to its original destination of B, to be back on course. Alright, so let's see how that value or solution looks like in the diagram. So this is the angular rotation that the ship must undergo in order to be back on track, and the value of theta, like we found out earlier, is 64.2 degrees. Alright, so that's that. Thanks so much for taking the time to watch this presentation. You can feel free to subscribe to our channel for updates to other cool clips such as this. Please post a comment to let me know what you think about this presentation. I really appreciate it. More clips can be found on math.serve.com. Thanks again for watching, and have a wonderful day.